host now. See, what we are discuss here is this problem. Okay, so pentagonal plane of side 20 millimeter resting on HP on its side. So accordingly, and then inclination given with HP and the VP. Okay, so accordingly we have uh, completed this solution. Okay, so in first time stage already everything was given here. I have shared this page with all those remarks yesterday only. Okay. Now, getting solution in stage 1, 2, and stage 3. Okay. So, stage 3, which you have performed here, is done with one of the methods, and that method is called as a, I will write here, change of position method. Change of position. Okay. So, the way of getting third stage, that is the final front view and the final top view, by rotating this concerned view, in this case as it is resting on HP, so that second stage top view will be rotating in third stage. Okay, so means we are changing the position of this view with inclination whichever is given. Okay, so method is change of position method. Okay, but can we do it, perform it with alternate method without going for changing, means copying this item here, okay, as it is with all those, dimensions. Okay, is it possible to do it in alternative way? Okay, that we are going to discuss, and that method is called as, if you wanted to combine it with the second stage, that method is called as a auxiliary plane method. I will write here auxiliary method. Okay, then means you need not go for change of position method. Then the alternate means you can skip this part, and instead of going for change of uh, position method, you can do it with the auxiliary plane method. How you can do it? Same principle you have to use, but just simple technique you have to adapt in getting this auxiliary method here. See, surface inclined with HP that we have taken, you assume that we have completed this first stage, then second stage. Now we'll be doing the third stage by auxiliary plane method. Okay, auxiliary method. So how you do it? You have to understand what is inclined. Out of as far as the pentagonal plane is concerned, its resting side is inclined. Resting side, which one is the resting side? This AB. See that in front, first stage, second stage, even front view, you will find A and B side that is on horizontal plane like this. Okay, A and B that is on horizontal plane, resting side on HP. Okay, so that side is given inclined, given at 45-degree, means instead of keeping it perpendicular, now we have to change it by making sure that this line becomes inclined at an angle of 45-degree with vertical plane. Okay. So instead of copying this, what we'll do, we'll follow a simple technique here, that is possible with this auxiliary method. Okay. See, as per this problem statement, this resting side is inclined. So what we are going to do, that resting side we are going to extend further. We'll extend it. Okay, we'll extend this line. Okay, so we have extended it to certain height here. Okay, you can take it to any side, maybe vertical, but as the space is available on the bottom side, and we are taking it here. Okay, on this line, mark any one point, any point here, any point. Okay, and through this you have to take the inclination. The inclination which you have taken here, 45 degree. Okay. Same you can adapt here by taking the same value. You can get the angle. Okay. So again, you just use the protector here and you will be taking the angle 45 degree. Okay. You'll be taking the angle 45 degree. Okay. So then I will try to get this line. So now I will say, I will take the line like this. Okay. Even I will name this line as a x1 y1 line. Previous line was this xy line. Now I will say it's a x1 y1 line. Okay. This angle is 45 degree. What exactly we have done? Instead of taking this 45 degree here, we have extended the side which is resting on HP, and to that line at certain point. See, this point might be here, but what happen if you will take this point and drop 45-degree line, it will be going to get mixed with this second stage top view. To avoid that, at a certain point you have to take that, so that it should not be going through this second stage top view. Okay. So what exactly I have done? Same thing which we have done in change of position method, similarly, but with certain technique we have got it. Okay. Then next, you have to have a line through each point of this top view. Each point from this top view. Before that, I will explain you what how you have got this front view in change of position method. Taking projection through A, taking the projection from here, second stage front view, B point, C, then you will understand the point C. Okay. And then horizontal projection from point C from second stage top view means this much distance from XY line means actually we are taking the distances from the XY line for each point. Even see for D, we are projecting this, taking the projection means we are projecting this distance, right? So same distance it happens to be here. Okay. So using the same concept, we'll try to get the answer here. And once I show you how to mark the point, definitely you will understand that. Okay. So see, first of all, set this roller scale or maybe a minute after whatever you are using. Okay. Start taking the projections from A, B. I will be taking it from even A and B. Okay. Before I take it from the distances from XY line here for the remaining point, let me tell you that point A dash and the B dash, these points are on XY line. They are not away from the XY line or above HP by any distance. So immediately here, I will mark these 2 points and I will name it according to the present scenario here. So I will say A dash and this point B dash, right? A dash and B dash. If you compare this A dash and the B dash, you will find in change of position method, A dash and B dash at same distance, means whatever the distance here, you will find it. If you compare it, you will notice that it is equal. And these 2 points we got on the projection of A dash and B dash. And of course, A dash and B dash is a XY line. So that's why similarly, we got this point. Okay. Now, with this, it is difficult to understand maybe, but now if I move to the next point after A and B point, I will go very slowly so that you will understand it. Okay. See, I will be taking the projection perpendicular to this. These lines are perpendicular to XY line. Remember, these lines are perpendicular to XY line. Okay. Whatever these projections you'll be taking it perpendicular to X1, Y1 line. Okay. Let's see point C in change of position method, that your point C is away from XY line by this much distance. Okay. Whatever the distance from here, that distance that is going to be here. So what we'll do here in this change of auxiliary plane method, from XY line, we'll be taking the distance of EC. We'll be taking the distance of EC and EE. Oh, sorry, XY to E and C point, right? And uh, as far as the projection from C is concerned, we'll keep metal end at X1, Y1 line and we'll cut this extension. Okay. So here, which point we are going to get? We'll get the point C. We'll say C dash because this is going to be the final front view. Okay. Then we'll take the projections perpendicular to X1, Y1 line, and that I will take it here. Okay. Then let's check how much is the distance of second stage front view from XY line. The distance is this one, right? This is the distance. Actually, in change of position method, the same thing you got, right? So ultimately, so here you will take the distance and we'll be keeping the metal end at X1, Y1 on this extension of D here, and we'll cut it, that extension, and it cuts here at this point. So immediately I will name this point as a point D dash, right? Now the point remains point E. You continue the same procedure for E. Taking projections through E. Okay. Then again, you have to see how much is the distance of E dash or E dash from XY line here. So this is what the distance. So I will be taking this distance now. Okay. And on this extension from X1, Y1 line, I will be taking this. Okay. I will be going to take it and it is going to be happen on this arrow here. See. So this point is going to be the point E dash. Okay. Then you can join these points in a sequence A2, A dash, B dash. I will join it. I will make it a bit dark so that you will notice it properly. Okay. So this is A dash, B dash, then B dash to C dash. And why I am showing it with this answer, previous work is because you will understand the actual difference in that. Okay. So how this change of position method and axial method, uh, the procedure is. And secondly, you will understand that the answer which you are going to get, that answer will be absolutely similar. Okay. Yeah, sorry. See, this shot, the answer which you have got as a final front view. If you compare it with this one, it is identical one. Okay, little here and there with you can say the measurement. Okay, forget about that. Okay, so but this A and B as it is here, then C distance at this distance, so similar distance you are getting here. Even for sorry, point D. Oh, sorry, I got something wrong. This is the point D. Okay, I think this point I have not taken. I think D, or might have marked bit wrongly. I'm taking this distance and or an extension of this D. Yes, yes, yes. This D point is going to be here because this much is the distance of point D. Okay. D to this distance, that same distance we are going to project by taking it from the this point. Okay, so it is going to be the point here. So I will name this as a D dash. Okay, and then I will join it. Okay, and then I will be joining D with E. Okay, so this what you the answer. I will make it the little with the different color later on. Okay, I will give you. Okay. Now we compare this final stage front view with auxiliary method and with change of position method, right? And you will find that it is one and the same. So changing the position of this top view with the new position, we can avoid it by following this auxiliary plane method. Okay, you can follow it as whatever it is explained here. Okay, and definitely it will be convincing to you. Okay, Rujita, you stop sharing and stop recording now.